You may have heard about software factories recently. And if not, maybe you heard about loops or automations. They're all circling this same idea of throwing away our 50 Claude Code tabs and replacing them with agents that trigger whenever you file a GitHub issue or send a message on Slack. Before, this was a very corporate or team way of doing things, but now it's becoming my default for just managing personal projects on GitHub. So I want to show you what a software factory is, why you might want to explore one, and how you can set one up in your garage for whatever you're working on. So let's start by breaking down a software factory. This is an article that Zach Lloyd put together at Warp that actually walks through step by step how you could set one of these up. And it starts with this diagram that shows you the cycle that you go through if you're running issues through a factory. Now, the idea is pretty simple. We want to start by tracking whatever we want to work on a task board. If you've used GitHub or Trello or Linear, you know what this looks like. You report your feature requests or bug reports, and then you have agents go and work on them. Now, the rest of this is where it gets interesting. Before, you might track all the work you need to do on a task board, and then when you need an agent to go work on it, you would open your terminal, paste a link to that issue, and then ask it to start chugging. But in this world, we're going to set up triggers so that agents can jump in and do all of this stuff without us intervening manually. Now, if you feel like this is really far off and I'm not spending the token budget to set all this up, I totally understand that. This is basically a North Star, where 1 or 2 years into the future, if you squint, you can imagine if we apply these agents in a way that's more efficient, if we actually think like engineers about this, the perfect vision would be something like this, where instead of pulling down tasks whenever you need to do them, agents hop in with the appropriate skills and tools available to handle each part of a sort of assembly line. So now let's zoom in on some of these components to talk about how they work. So the first thing we want to talk about is triage. This is the simplest aspect of a factory, and it's the onboarding point I would recommend to just try out this idea, where you would write a skill that describes how this agent works, and it would review the issue, look for duplicates on the board or prior art around whatever product decision that you're making, investigate in the code base, so make sure the agent can access the code base, and then decide if it's ready to work on. If it is, maybe you want to hand it off to an implementation agent straight away. And if it's a feature that needs more information, you might jump over to a spec agent. And this is how I typically do this sort of thing, where if I notice an issue needs more detail, it gets labeled as such. I clone it locally and maybe go through a grill me session so that I can reach alignment with an agent on all the edge cases and problems that you run into. If you're unfamiliar with grill me, I don't know how, but Matt Pocock has a great video about that. Basically ask the agent to ask you a bunch of questions to work out the finer details. And then from there, you can write basically a planning document. In our case, I actually have a more opinionated version of this, where it's a planning document that describes the end-to-end product flow for testing, and also the system architecture so that you know what models it's going to touch, where some of the bottlenecks are going to be. So that way, when it actually implements, it's going to have more information than just a standard one-shot. And then you'll probably want some sort of implementation agent. This is the simple one. This is what you clone down and ask Claude Code to do, right? And the instructions might be light or heavy depending on how complex your project is, as long as you describe the guidelines of your code base in an agent's MD and you include some sort of testing strategy like how to open your Electron app and click around, or how to use the Chrome dev tools. All of that will give the agent enough to go implement it without you starting the session yourself. And verification goes hand in hand with what we talked about over there. You want some skills that describe both your unit tests and also your end-to-end click-around strategy. The continued gold standard for this, if you just want to start simple, is make sure the Chrome DevTools MCP is available to your agents, because it lets it run browser scripts to click around a UI and gives it a screenshotting tool to verify that its work looks correct. At a bare minimum, if you're doing web development, you need something like this. Although you can go further and use computer use with Codex, or if you're building a desktop app, inject some scripts inside of there. Just make sure there's some strategy so it's not just coding blind, it's actually actually able to look at the work that it did. And then by the time all of that is done, you will want some tooling on the review side. I'm sure you've gotten ads for CodeRabbit or using Warp's own agent for PR review. All that stuff is fair game. I would put something like that on the back end of all the work that your agent does. So by the time you actually look at a PR, an agent was able to give a review and leave some feedback. And of course, you need your CI/CD that you've always had. As for self-improvement, kind of beyond the scope of this video, but I've done a whole separate video about how that might look. And in the end, we've kind of described a software factory. Now you might be thinking, okay, I can run all of this stuff manually. In fact, it looks a lot like what I already have. Like maybe I already have an end-to-end testing skill in my repo. Maybe I already have something like CodeRabbit set up. Maybe I have a skill that describes how my plan should look. Really, the only thing a software factory is adding is some sort of automation piece for all of this. Instead of you cloning down with Claude Code and running the triage skill, cloning down with Claude Code and running spec, cloning down and running implement, cloning down and running the review skill, you have triggers to do all of this stuff automatically. So imagine you file an issue. The triage agent wakes up and triages the issue. Maybe on a Cloud Runner, maybe on a GitHub action, something like that. So you don't have to do any work, it just kind of starts happening. And then if triage says this is ready to implement, maybe it hands off to an implementation agent, which then does some computer use, which then opens a PR, which triggers the code review agent. You can kind of see where I'm going with this. We're pulling out the human intervention piece and applying all the skills you're probably writing yourself. So let me show you how you could set this up in your garage, both with a small project and also ratcheting up to a larger project to show how it might scale. And I'm going to be using GitHub for this. You can use other task boards like Linear or Jira in a company context. But we all have GitHub side projects of some kind, so I like using this as a starter example. And this here is an open source project that I maintain. It's called Hubble. It's a note-taking app that feels like Apple Notes, but lets you work with Markdown and even create visualizations inside of the app. That sounds cool, come contribute. But if you're curious how we manage our contribution flow, let me show you. So we get our issues in here, and I've started setting up some automated agents to kick this through a factory to make them easy for me to review. So for example, there was an issue recently about adding MCP support to this Notes app. So an issue came in, there were a decent amount of details listed out here with phases and such. And I wanted to set up an automation to say, when someone files an issue, can we go investigate it and decide what to do with it? So here I've written a triage agent, like the one I showed you earlier, wrote up a little skill that describes what to do. So here it's responding to the issue filer in a kind way. Opus is great at that, as you can imagine. And it makes a decision on what it should be. So it decides whether it's ready to implement, which means start coding, or needs discussion, which means maybe I want to pull it down and write a spec, use grill me, all that good stuff. And it's also told to list out anything that it found and follow-up questions if it needs discussion. And this one certainly did. So it highlighted some aspects of his issue that are worth my review. For example, how this relates to cloud syncing, which is another work stream that's being added, and also some finer questions about the API design that are worth working out. And then we have those follow-up questions. So how should this be maintained? What package should it go in? How are we going to scope the API? Should the MVP include read access or should it include read and write? Get the idea. And because it's asking those questions, it means the external contributor can just respond. So by the time I look at this issue, I'm not just looking at this wall of text here. I'm also looking at a little thread where the filer came in and said, those are some good questions, let me flesh those out, and then I'll tag a maintainer to see what the decision should be. Should this be a further discussion? Should this be a CLI versus an MCP? So we're going to keep following up with this, but it did save me a bit of time because on the issue page I can see, oh, this needs discussion. That means I should hop into the issue and look at it. And it also saved me some questions I would have asked otherwise. So when I hop in, it's actually ready for me to review. I have another example down here which got marked ready to implement. So this is actually an issue that I threw out there. This was just a really vague ask that I had where I wanted to have backward and forward navigation in the app. We haven't implemented it yet. So I just described what I want to do and left the rest blank. So it labeled it needs triage, and unsurprisingly, it decided this needs further discussion. So it did a little investigation and actually decided, yeah, we could implement this. This is what I noticed in the code base. These are some things that are worth speccing out. And then another person who was interested in adding this hopped in and fleshed it out for me. How amazing is open source, right? And because the agent came in with some springboard jump-off questions, it means I was able to hop in, and we already had a bunch of stuff worked out. I didn't have to spend the time, really. So from here, I actually pulled this down into an agent, had a back and forth planning session, wrote those into these spec documents right here, and then I marked it ready to implement. And I actually forgot that I had a ready to implement set up here, so I invited the contributor to contribute. I was like, oh, an agent already did it. But either way, this is actually a great demonstration of how that can work. So I pulled it down because I saw the discussion. I wrote up a plan, and I committed it to GitHub in this case. And just by tagging ready to implement, a Cloud Runner was able to stand up and say, all right, I'm going to go ahead and implement that. I'm also going to give you a session link. That's something that Warp helps you with, by the way. You can use all sorts of automation services. And then it found some information and opened a draft PR. How great is that? So I didn't even have to pull this issue down. I just did a bit of planning, pushed up a spec, and on the other side, I get a implemented PR. And it even shows you the end-to-end desktop verification because I gave it a skill that describes how to test the desktop app. And I'll give you one more example that just popped up. This was a question about spell check suggestions. And the agent decided this was ready to implement right away. So an agent's gonna hop in and pick this up for me. So this is where you get into the zero friction scenario, where you can go straight from an issue filed to a PR ready for review. So now let's actually see where the rubber meets the road, showing you the GitHub workflows and the skills that are backing this whole thing. If we hop into my skills folder, I've written out skills for a couple aspects of this flow. You'll notice triage and implementation are listed out right here. I'll hop into triage first. So in this skill, it just describes, I want you to assess this issue, and there's two GitHub labels that I use right now. One of them is ready to implement, which means an agent could work on this. It's one-shotable. Or it needs discussion. It's not ready. Maybe I need to pull it down and write a planning doc or a spec doc, whatever vocab you use. And here is where we describe the tools available. So this is running inside of a GitHub action runner, so it has access to the GitHub CLI. So we ask it to look for existing issues on the board already. And I've set up my workflow to only give it read access. So it's not able to write a bunch of issues on my behalf. That's a security vulnerability you definitely want to be on top of. So make sure these agents only have read access when they're generating all of this. But down here, we describe what these criteria mean. So this is when it's ready to implement. This is when it needs discussion. And then it just returns this raw JSON result that the GitHub workflow that's running this agent will be able to turn into an issued comment in the thread. And if we go look at the GitHub workflow, you can see exactly that getting generated here. There's a lot of extra stuff like applying labels if none exist on the issue, but here are the main parts. So you'll notice that it has issue and content read access. The agent's not able to write things on your behalf. Otherwise, it would be able to edit and delete issues. Don't allow that. So give it read. Here we're using Warp as the backer for the agent. So this is a GitHub app that lets you stand up an agent inside of a GitHub action. You can also use something like Claude or Copilot or even local automations if you want to. That part is up to you. The important part to know about is writing a skill that describes your triage and deploying an agent that looks for issues and runs the triage skill. So you don't have to do it. And down here is where we parse out that JSON body I showed you earlier and create a comment. I also have a skill specifically for the verification step. Because I'm building an Electron app, I invented a little flow that gives the agent a backdoor to run scripts inside the desktop app and take screenshots. So this describes all of the tools available. And Fable recently wrote some gotchas after it ran this skill, because that's just what Fable does. And if you're wondering how you can set this up yourself, first you can just go to the Hubble GitHub repo, copy my workflows, and modify them to your taste. We also set up a skill that programs all of this for you, though, if you're interested. So I will put this article in the description, But at the end, there's a skill that you can install that will allow the agent to stand up all of these automations using Warp CLI. And it'll let you describe, here's my GitHub repo, here's my triage skill if you have a custom one, and then it'll wire it all up for you. Now, to expand your mind a little bit about how this can scale, here's a larger open source repository using a very similar setup. This is the Warp repository. As you can see, it gets a lot of activity. If you've looked at OpenClaw, it's worse, I promise. But in order to stay on top of this, we needed an automated system. We can't afford to run a Claude Code instance on our laptops for every issue that comes through. So we set up a triage agent that comes in at the front door and looks at everything. Here it's more opinionated in how the response gets structured. Maintainer details get collapsed into this view, and if something's a duplicate, for example, it will flag them as duplicates and reference the appropriate GitHub issues. We also have labels that describe whether something needs a spec or whether something is ready to implement for an automatic agent to come in and make an initial draft PR. So same stuff, different scale. Now you might have a more existential question seeing this, like, if we're not pulling down tasks to work on them with agents anymore, it's mostly automated, what is the role of a software developer in this brave new world? Well, at this moment, I think what we're going to start doing is building the meta tooling that takes these agents that we've been having fun with on our local machines and applying them to run automatically at different steps of the process. It's going to be a lot of fine-tuning skills, creating automations and cloud workflows, refining token cost by deciding which models should be used at each step, also multi-orchestration strategies. All these next level problems are going to be the frontier for, I would say, the next 5 or 10 years as we evenly distribute these ideas across all the software that's being developed. I personally think it's a really exciting problem. It's actually why I've changed my LinkedIn bio to Software Factory Foreman. Maybe ahead of my time. But if this excites you, go check out that blog post in the description to set up your own software factory. And if you want to contribute to one, Warp and Hubble are both open source. With that, I'm going to be posting a lot more videos about coding agents. See you in the next one.